Hi, welcome to another video. In today's video, we are going to solve longest common prefix problem from the Leetcode. In this problem, they will give an array of strings and we have to find out what is the longest common prefix for those strings. If you consider this first example, here they have given three strings, flower, flow and flight, and we have to find out what is the longest common prefix. If you observe all these three strings, you are going to find out that FL is the common prefix among these three strings. So our output should be FL. So similarly, if you consider the second example, dog, race car and car, there is no common prefix because it starts with D, it starts with R and it starts with C. So we don't have a common prefix here. So our output should be an empty string. Let's try to solve this problem using Go programming language. So how I am going to solve this problem is, first I will get the first word. So I will take the first word and then I will consider its first character, and then I will go through all the strings to find out if it is the first character for all the strings, all the remaining strings. If that is the case, then I am going to append that character to our answer. And after that, I will consider the second character of the first string, and then I am going to compare it with all the strings second character. If the characters match within the respective positions for all the strings, then I am going to append that character to our answer. This explanation becomes clear once we start implementing the solution. Let's try to implement the same solution that we were discussing till this time. The first thing is, let's try to total number of words. This will be equal to len of strs, and after this, let's consider, we don't have to consider the first word. For I, C in range of strs of 0. This is the first word, strs of 0. This is the first word, and you should write like this for loop. And now we have a character at an index, and then we'll start with the first word itself, because it helps in taking care of some edge cases. What if there is only one string given to us, and at that point we should not skip that word, otherwise we have to write a special if case for handling that thing. For j is less than total number of words j plus plus. J is not declared here. Okay, now let's consider this current word. Current word will be equal to strs of j, and what we should do is, first we should check if I is greater than or equal to, let's do this thing as well, current word length. If this is equal to len of strs of j. If I is greater than or equal to current word length or our strs of I, the current word that we are considering, current word of j, not j, I, is not equal to C. This is the first word character that we are considering. We are comparing characters in the respective position for all the strings. If this is the case, then we have to break out from this for loop. And let's also create a variable for our answer, longest common it as a string, and we also need a boolean variable, and we are going to set this variable as true before breaking out so that we can stop the iterations. If we reach till the end of all the words, then that means that character is common to all the words which are present in the array. So if j is equal to total number of words minus 1, then we have to append this particular character longest common prefix will be appended with string of C. And finally, before iterating over, we will check if done is true. If this is the case, if done, then we will return longest, I think it is longest common prefix. And even at the end, what we are going to do is we are going to return longest common prefix. There might be some compilation or compilation or typo errors. Let's see. But what we are doing here is we will consider the first word, and for that each character in that first word, we are going through all the words, checking if the corresponding character for that position is equal. First we compare F with this F and this F, and then we will compare this L with this L and this L, and then we will compare O with this O and this I. Since here it becomes false, we don't reach this case and we are going to break out of this for loop. And since done is set to true, we will return whatever the longest common prefix that we have got till this time. Let's run the solution. There might be some errors or typos. Let's see. Okay, we have total number of words. Okay, this is undefined. Let's run it again and check if there are any more errors. Current word of I is not equal to C. Byte and rune. Okay, let's convert both of these things to byte, because when we use range to iterate over string characters, it gives output in rune. So let's convert both of them to byte, and let's run the solution again and check whether it passes the initial test cases. Yes, as you can see here, this is passing the initial test cases. Let's submit the solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. Let's discuss about time and space complexity. So what is the time complexity for this solution? What we are doing here is, for each character, we are going through all the remaining strings. So what happens to the time complexity? The time complexity is we go through each string for each of the characters. I think the time complexity, let's discuss about time complexity. Time complexity. So this is for each len of first word multiplied by n. So this is the time complexity for each letter in the first word, we go through the entire string. So we do it len of first word times. This is a time complexity. And what can be the len of first word? So do we have any limitations? So STRS, I think it is a constant. So our time complexity is O of n, since len of first word can be at most 200. So our time complexity is O of n. And what is the space complexity? For space complexity, we are not using extra storage apart from while using it for longest common prefix. So that can be constant. So we can say it as O of 1 because it's a constant. The length of the word cannot exceed 200. So at most we can use 200 characters to store the longest common prefix. I hope this solution makes sense, and thank you for watching this video. If you are interested in learning more about other data structures and algorithm related problems, please check out other videos from my channel.